Hello students, myself Dr. N. Ratnavati, working as an assistant professor in General Engineering Division of Science and Humanities Department of RMD Engineering College. In this video, we are going to discuss the transient response of series RC circuit for DC step input. So before going to the topic, first we should know that what do you mean by transient response? So transient response is nothing but that is a short duration of a pulse. So whenever we have to give the excitation over the RL circuit, that is the main important thing is your whether your circuit is containing your capacitive or inductive elements along with the resistive element, then definitely we have this transient response. So what do you mean by this transient means? Transient is nothing but the short duration of a time. So within a short duration of time, that is when the switch is yes is closed at time t equivalent to 0, so automatically the current passing through the consider this diagram. So in this diagram, whenever the switch is closed at the time interval t equivalent to 0, then your voltage passing through the, that is your current passing through the resistor and capacitive elements, it will varied. So that variation is the main cause of this transient response, and this is available only for the short duration of a time. that that's why it is called a transient response. Then after that it will reach the steady state value. So first we should know that what is a transient response of a series RC circuit. So this is our RC circuit diagram. So see to that here one resistor and capacitive element is connected with this voltage source V into U of t. So now this switch is closed at the time interval t equivalent to 0. Then now the current is passing through. Now we are taking the current passing through this closed loop as a I of t. So already we know that in a closed loop circuit, so already we know that in a closed loop circuit, we need to apply the Kirchhoff's voltage law for find out the current passing through the each and every passive elements in the circuit. So for that, first I have to apply the Kirchhoff's voltage law here. So here they are given in the problem statement itself, that is your DC step input. That's why I'm taking here the magnitude of your input DC excitation is a V, and your input in the type of one step input, that's why U of t. So applying the KVL to this closed loop, then we are receiving V into U of t minus R into I of t minus 1 by C into integration of I into dt is equivalent to 0. And already we know that what is the current passing through the capacitor. So the current passing through the capacitor I of t um, is given by C into d by dt of Vc of t. So this is a current passing through the capacitor. Now substitute this I of t in this equation number 1. That is in this equation we need to substitute this. Then we are then see to that here we are receiving R into I of t. So instead of this R into I of t, we need to substitute instead of this I of t C into d by dt of Vc of t, and again here 1 by C into integration of this I into dt. So here instead of this I value, we need to substitute here C. So now both the numerator and denominator is having the C, it will get cancelled. Then both the differentiation and integration, it will get cancelled. Then we are receiving only Vc of t. So that's why your equation, it will become like this. So now this is your voltage through your series RC circuit. V into U of t equivalent to RC into d by dt of Vc of t plus Vc of t. So consider this is your equation number 2. And already we know that the initial voltage across the capacitor, we need to consider this one as a Q naught by C. And now we need to apply the Laplace transform of both the sides of this equation number 2. Why we go for Laplace transform means because transient response means we need to define the transient response with respect to the time interval. So whenever if you have an Laplace transform, then we need to apply the inverse Laplace so that only we are getting the output in terms of a time interval. So now we need to apply the Laplace transform on both sides of this equation, and already we know that what is an u of t is nothing but your step input. So if you are taking the Laplace transform for the step input, then we are receiving 1 by s. So v by s is equivalent to RC. Already we know that your d by dt, that is your differentiation of this any. If you are taking the Laplace for the differentiation term, any differentiation term, then we are receiving S into that particular term. So that's why here S into Vc of S minus Vc of 0 is an initial value of the voltage passing through the capacitor at time t equivalent to 0 plus your Vc of S. So now already we know that V naught equivalent to Q naught by C. So RC, if you are taking RC as a common, then S into Vc of S minus V naught plus Vc of S. So V of S, if you are do the simplification here, V by S plus RC into V naught equivalent to Vc of S plus 1 plus RCS. So now if you do the simplification, then we are receiving Vc of S equivalent to V by S into 1 plus RCS plus RC into V naught divided by 1 plus RCS. So here we need to apply the partial fraction. So if you are applying the partial fraction here, then we need this denominator term in the form of S plus 1 by S plus term. Okay, so that's why here we need to apply some mathematical simplifications, and we are receiving V by RC into S, V by RC divided by S into S plus 1 by RC plus V naught. This RC and RC will get cancelled. So V naught divided by S plus 1 by RC. So now we need to apply the partial fraction here for this term. So we are receiving, that is instead of this V by first term of this equation, that is for this equation, first term of this equation, we need to apply the partial fraction. Then we are receiving A by S plus B by S plus 1 by RC. So if you apply the partial fraction, then we received the values of A equivalent to V and B equivalent to minus V. Now we need to substitute these values in this first term of this equation. So we are receiving V by S minus V divided by S plus 1 by RC plus V naught divided by S plus 1 by RC. So now it's easy to find out the inverse Laplace for this particular equation. So if you are taking the inverse Laplace, Vc of t equivalent to V minus, so because already we know that 1 by S is nothing but your 1. So that's why, that is, if you are taking the inverse Laplace for the 1 by S, then it will become 1. So that's why here V minus again V by S plus A. So if you have the term that is inverse Laplace of 1 by S plus A, that can be rewritten as e to the power minus A into t. So here instead of an A, we have 1 by RC. So that's why here minus t divided by RC. Similarly here also plus V naught into e to the power minus t by RC. So if you are taking this V as a common, then we are receiving the voltage across the capacitor at the particular time interval is mentioned by V into 1 minus e to the power minus t by RC plus V naught into e to the power minus t into RC. So now we should know that what is the current through the capacitor. So the current through the capacitor, already we know that that is defined by I of t. So I of t is nothing but C into d by dt of Vc of t. So if you are taking the differentiation to this element, that is C into d by dt of, instead of this V into 1 minus e to the, that is instead of this Vc of t, we need to substitute this equation. Then again here that V naught value, it will become 0 because at the initial time interval. Then after that, if you simplifying this term, then we are receiving what is the current passing through the capacitor. So what are all the prerequisites for this transient response of your RC circuit means? So in this transient response of this RC circuit, first we should know the fundamentals of your Laplace transform, be familiar with the Laplace transform and KVL, then the remaining things are very easy. So the transient response of series RC circuit is an very important. And one more thing, if you have that values like R equivalent to 20 ohms and C equivalent to 10 microfarad. Instead of this R and C constant values, if you have an variables like this, then we need to use the same procedure to derive the equation. So that is an main feature of this derivation. The derivation part is very important. Thank you all.